In order to understand the appeal of programming, we should familiarize ourselves with two core aspects of it: pseudocode and abstraction. What is pseudocode? Pseudocode is the natural human language used to explain the steps that a program will need to take. The pseudocode is for you, or anyone you're going to explain your program to. It's not real code that the computer will execute. Instead, it's kind of like a to-do list or a roadmap. An example of pseudocode would be, when the time becomes 11:05, play an alarm. Note that there's no computer syntax here. It's just a regular written sentence to describe the action of our code. You can flesh out your pseudocode for your program as much as you need before starting to write the actual code. It's intended to be as densely or sparsely detailed as you need for yourself in order for you to solidify your grasp on what your program needs to work properly. Now, what about abstraction? Abstraction, in programming, is the idea that multiple instructions can be lumped together into something that can be thought of more easily from a higher level. The same is true with most things in life. Let's use a hamburger, for example. The word hamburger is an abstraction. We understand when someone at a restaurant asks for a hamburger, they're asking for a patty, vegetables, condiments, sandwiched between two halves of a bun. You'll never find someone that tells a waiter, "I would like you to grill a patty to a safe temperature, place it on the bottom half of a bun, add some lettuce, onions, and tomatoes, squirt some ketchup and mayo on the top, and finally place the upper half of the bun on top. When assembled, serve it to me on a plate." No, we just say, "I'd like a hamburger." We as a linguistic species have collectively accepted that a hamburger is the abstraction of everything involved to make one. How does this translate to code? Well, if you think about it, pseudocode is simply the abstraction of your code. Except, we haven't written any code. That means it's a programmer's job, your job, to take that abstracted pseudocode and separate it into more specific instructions until you have something that's directly translatable into code. Let's say you want to make a program that just draws a circle on your screen. You have to ask yourself, how does the computer know what I want it to do? How big of a circle will it draw if I don't specify? Where will the circle be drawn if I don't specify? What color is the circle going to be if I don't specify? You can see how easily your pseudocode can explode with extra detail. Instead of draw a circle, we can flesh it out to say, open a window that's 400 pixels wide and 400 pixels tall. At the XY pixel coordinate 150, 250, draw a circle of diameter 200 pixels and fill it blue. From this point, if you intend to teach yourself how to program, you can research how to execute each part of that expanded pseudocode. How do I open a 400 by 400 window, you might ask? How do I draw a circle and specify its size, position, and color? For this video series, I will be giving examples of the JavaScript language inside the P5 web editor. Details for both are in the description. Let me show you the real code for my extended pseudocode. First, we set up our program by telling it to open a window that's 400 by 400 pixels. We then begin the draw process by defining the fill color of any shape called in the rest of the code. The three numbers correlate to red, green, and blue, with 0 being the lowest possible number and 255 being the highest possible number. This is just like Photoshop or Microsoft Paint. In this case, red and green are at 0% intensity, and blue is at 100% intensity, meaning blue is our defined fill color. If we wanted purple, we could use 255, 0, 255. Or if we wanted yellow, we could use 255, 255, 0. Or if we wanted sea green, we could use 46, 139, 87. Next, we call a function that draws the actual circle. Note that we are calling an ellipse function, not a circle function. Our web editor doesn't offer an explicit circle function, and that's because a circle is just an ellipse whose width and height are the same. We tell it to center the shape at 150 pixels over from the left side of the screen and down 250 pixels from the top of the screen. Lastly, we define the size of the circle. In this case, we set the width to be 200 pixels and the height to be 200 pixels. And there we have it, our first program as a channel. The trick with writing a program is that the computer will never make assumptions. It might seem like your code will assume some things, but actually, the person that wrote the language you're using decided to implement default instructions. For example, with our code, you might have noticed that the outline of our circle is black. That's because the authors of P5 decided that the outline of a shape should be black and 1 pixel wide, unless the code we write specifies otherwise. We could easily change the color and thickness of the outline, or remove it altogether if we wanted to. But I'm beginning to digress. I wanted to explain the appeal of programming. I myself, as a hobbyist programmer, find great satisfaction in thinking of an idea, breaking it down into its tiniest parts possible, and finding a way to make that happen with code. Pseudocode and abstraction are the essential first concepts to grasp when beginning programming. Start with your goal and brainstorm what groups of ideas you need to flesh out in order to achieve that goal. I started with minimal conceptual knowledge in programming, but I had an idea that I needed to see realized. Before I knew it, I was making plugins for Minecraft. I wanted to golf, see it snow, or even tell the AI to build a house. Now, I've practiced what I've learned, and I've excelled in my professional career because of it. Don't be afraid to dip your toes in the water. If reception of this video is well received, I would love to cover the basics of programming in more videos and ramp up to more complex topics. I'm thinking of starting with small clips explaining if statements, all the way up to video courses exploring machine learning. Please let me know in the comments if you would enjoy such a series. Scripting, recording, animating, and editing these videos can easily take days, so please stay patient while I get a pulse on your interest in the series. And with that, I'm going to end today's video. I appreciate your interest, and I hope I help you strengthen your grasp on programming. See you next time.